We are ChemFeed.
Now if you're looking to learn about chemistry and feeding that knowledge, you come to the right place.
We will lead you to an energy-efficient lifestyle.
Our mission is to find the most efficient way to use hair dryers.
Our hypothesis is that the cool setting on a hairdryer will use less than the heat setting because it takes extra energy to heat the air.
But first, how much does a typical hairdryer use?
Well, Jesse, it says here that on cool, you use about 70 watts, but on heat, you use about 1,500 watts.
And now we will commence our mission in 3, 2, 1.
For the materials, you will need a surge outlet, a kilowatt meter, a timer, an extension cord, sticky notes, a marker, tape, at least 6 hair dryers, and lastly, a data table.
So the first step you want to do is lay out all the dryers that will be used in your procedure at the same level. And using the colored post-its, you're going to label all the models of the dryers and their average electricity usage to keep track of each one.
Plug in the kilowatt meter into the surge protector, which is also already plugged in, along with the first hair dryer. Next, make sure the hair dryer settings is put on cool and high for each hair dryer. Then once that is checked, leave the hair dryer running for about 60 seconds. Once that is complete, repeat the same steps, except change the cool settings to hot.
Each time we had a blow dryer plugged in, we kept track of the kilowatt meter and kept track of how much power was being used.
And that was the first trial of our experiment. Before proceeding to the second trial, wait for a while so that everything cools off and is back to normal.
The second trial is identical to the first trial, and it is primarily there to ensure that the numbers received in the first trial are reasonable.
The graphs depict the results of the two trials. The blue bars depict the wattage when the cool setting was used. The red bars show the wattage for the dryer's heat setting.
Now that we have collected all our data, let's move on to discussion of this experiment.
So, judging from these graphs here, I would say that our hypothesis was fairly conclusively proven, since even though the numbers are not completely consistent, there is still a significant increase in the energy usage of hot compared to cool. Well, power consumption, but those amount to the same thing over a given period of time.
So, however, there are a few sources of error in this experiment that we have to go over.
First, there's the issue that we might not have had enough time in between the trials to let the blow dryers set back to normal temperature.
Also, there's the error of not giving the dryers enough time to fluctuate its numbers. But there can also be the error of which one is more efficient, because if it takes more time for it to dry something on cool, heat would be more efficient.
And that sums up our experiment. And so, we're out.
Pretend that did not happen.
Okay.